Lesson 2-1, writing equations. The objective today is to translate sentences into equations and also to translate equations into sentences. So the standard that's covered today is Algebra 1.9.1. We're going to start off with a couple of definitions. An equation must have an equal sign. And the same vocabulary that we discovered in when we were writing expressions apply today. So let's translate to an equation. Let me hang on just a second. All right. Example A. A number B divided by 3 is 6 less than C. So we'd have to write an equation, and they're actually telling us which variables to use in this. Be careful with how you write things. Make sure you write the operations the way that we're supposed to with division. Be careful of the word less than. Is there anybody that wants to attempt giving me the correct answer on a number B divided by 3 is 6 less than C? Cheyenne, what are you thinking it'll be? Okay, B over 3, and say it again, say the rest of it, equals C minus 6 is exactly right. And all you're doing with that is translating this into an equation, and we have done that. So B divided by 3, make sure you do over 3 for division. And where you see is, that's your equal sign. 6 less than C, the word than pulls the first thing to the back, so C minus 6. Okay, example B. 15 more than Z times 6 is 11 less than Y times 2. Now we kind of want to write this in the format that we would normally be used to. Ethan, what are you thinking?
Z6 plus 15.
Okay, do we normally write Z6?
Z times 6.
How do we normally write that? Do we put Z?
6Z
Yes. So 6Z, now what?
plus 15
Plus 15
equals 2y minus 11.
2y minus 11. Yeah, that would be the standard format that we would use. We wouldn't put the variable in front of the number. It's always the number in front of the variable. So 6z plus 15 equals 2y minus 11. Good. Example C. 6 times the sum of a number and 2 is the same as the difference of 4 and n. So we have to be careful here. 6 times the sum of a number and 2, we don't know what that number is, and they don't tell us what variable it is the same as the difference of 4 and n. Jared, what do you think?
6 times the quantity of x plus 2
Okay.
equals 4 and 7.
All right. 6 times the sum, that means in order for the sum to happen first, you got to put it in parentheses, the sum of a number and 2. So he chose x for the number, x plus 2, equals, that is same as, difference of 4 and n. So when they say the difference of 4 and n, where the word and is, that's where the sign goes, which would be minus 4 has to come first, n has to come second. Okay, questions about that? All right, I'm going to go ahead and scroll down here just a little bit more. The next one says we need to translate that into a sentence. So we need to write the words for 12 minus 2x equals negative 5. And just like we did with phrases, I honestly would use as simple as vocabulary as you can get so you do not make an accidental mistake. So, Megan, what do you think?
2 times a number is less than 12.
Okay. 2 times a number is less than 12. Okay. And I'm going to say, all right, so equals -5. I was thinking of something a little simpler than that, but hers actually works. I might actually write 12 minus 2 times a number is the same as -5. Any of those would work. Or you could say the difference of 12 and 2 times a number is the same as -5. Okay, we must have a question. What, Evan? You could put 2 times x. Yes. Yes.
Didn't you say that the word is means equals?
Yeah,
Is
you-
less
2 times a number is less than, well, you have,
Well, wouldn't it be 2 times the number less than 12?
okay, that would probably alleviate the problem if you're worried about the is, yeah. 2 times a number is less than 12 times, yep, you're probably right. Probably should take the word is out of there. Probably should take the word is, oops, and I did not mean to delete all that. Hold on, let me see if I can get that. So, we should probably just eliminate the word is. 2 times a number less than 12. Yep, that would probably make it better. All right, any other questions? All right, let's see what we've got coming up. Based on the given information, define a variable and write an equation. So when we talk about defining a variable, it doesn't mean write the definition for the word variable. It means that you pick the variable that you're going to use and you actually use that variable then in the equation that you're going to work on. So a team of gymnasts competed at a meet. Every member won 3 medals. There were 45 medals in all. How many gymnasts are on the team? So the important part is picking out what, first of all, figuring out what you're solving for. And then what would make sense to be a variable to represent that. And then use that variable in an equation, not a solution, in an equation to write the equation, then you would work on solving it. So that's always kind of the hard part, writing the equation without writing it as a solution, sort of. So first of all, a team of gymnasts competed at a meet. Every member won 3 medals. There were 45 medals in all. How many gymnasts are on the team? So what are we actually solving for, Tora? How many gymnasts? So what would be a good variable for that?
G.
So here's how you define a variable. Let G, and you have to use the word let, that's part of the definition. Let G equal gymnasts. Okay? And Tora, got a question?
Do we actually write let G equal G?
Yes, you actually write let G equal gymnast. All right, Tora, so we're going to use G in this equation. So every gymnast, every member won 3 medals. There were 35 medals in all. So what equation using G would represent that situation that we could later take it and solve for how many gymnasts there were? 3G equals 45 would be exactly right. So 3 times the number of gymnasts equals 45. You don't want to do the solution. A lot of people would have the idea, oh, I got to take 45 divided by 3, and they'd say G equals, well, yeah, that's how you solve it, but this is how the equation would actually look. 3 times the number of gymnasts is 45, so 3G equals 45. Very good. Okay, now, F. A store sells notebooks. They have a 25% markup. The total cost is $3.75. How much does a notebook cost? Okay, so this one's a little trickier. This one's a little trickier. There's a little more to this one. So we're going to talk about it maybe in parts here. I'm going to scroll down just a little bit so I have a little more room to work. A store sells notebooks. They have a 25% markup. The total cost is $375. How much does the notebook cost to begin with? Okay, first of all, we're looking for how much a notebook costs. So what I'm going to do is I'm going to let C equal the cost of a notebook. That's defining it. I know that in all it equals $375, but we need to talk about this markup a little bit. So we talked about this a little bit last year. Markup, a store, when they sell something, they have to pay a cost for it. They decide how much profit they want. That's the markup. They add that percentage on. So the markup, being the percentage, is the percentage of the cost. So basically, 25% is written as 0.25, and you have to take that times the cost. That is known as the markup. So to get the cost of the notebook, you would take the cost of the notebook plus the amount of markup. And altogether, that would equal $375. So that's how you do that one. It is a little more thought involved. So to find a markup, you take the cost that you already have, plus you add a percentage of that cost on to make it a total cost of what you're going to charge for the notebook. So C was the original cost, plus 25% time of that cost is the markup, and together it's $375. So that when you add those two together to actually solve, it would be 1C plus 0.25C, 1.25C, and you would divide. Okay, questions? Yes?
That one, couldn't you just write 1.25C?
I wouldn't. Let the person figure out later they're going to do that. You would do the original cost plus the markup. That would just really spell it out for them, okay? The original cost plus the markup, and that would really spell it out for whoever was solving. Okay, questions? Any other questions? So your job today is going to be writing equations from some word problems, maybe even some scenarios like the last two.